Hey everyone, this is the end result of a school project I did last summer. But before we get to this stage, let's rewind the video to where it all started. Here you can see a complete overview of the design I've drawn up in SolidWorks. This will give you an idea of what it will look like when it's done. So to check if the pipe I intend to use doesn't bend too much under the weight of the new pool deck, I use some hand calculations. So I've weighed the old pool deck, which weighs around 100 kilos. I've worked that load out to a equally distributed load, which comes out to be around 163 newtons per meter. Then I simplify the situation by cutting the pipe in two. So one end is the bearing block and the other end is the half mark of the pipe. We have two loads on the pipe. One load that pushes our pipe down, but also a load that pushes our pipe back up, which is our reaction force in our bearing block. Over here on the right you can see the two equations I used to calculate our displacement. The top one is for our equally distributed load and the bottom one is for our reaction force in our bearing block. Then we start filling in our values. The top equation is for the evenly distributed load that pushes our pipe down. The second one is our equation for our reaction force that will push our pipe back up. We subtract the two to get to the correct equation for the displacement. Then we can start filling in the values for E and I. E is our Young's modulus, which is a material property. I is line moment of inertia, which is based off of our pipe. Our pipe has an outer diameter of 154 millimeters and a wall thickness of 2 millimeters. So we fill that in our equation and then we can calculate the final displacement. So our displacement is 5.2 millimeters, which for this application is totally acceptable. To confirm my hand calculation, I will use the simulation option in SolidWorks and fill in the same values I've used to calculate the displacement by hand. So according to SolidWorks, the displacement is even less than I've calculated by hand. Now, let's start on the fun part and start fabricating this thing. I'm starting off by drawing some circles on a stainless steel sheet, which is about 5 millimeters thick. I will cut them out with an angle grinder. After that I will put them in a lathe and make them nice and round. By drilling a hole in a piece of plate, it's easier to chuck it up in the lathe and to make the outside diameter round. Using a bolt to secure the plate to the lathe chuck. Now the plates are nice and round, I will use a drill and a boring bar to screw the hole up in the center and size it up to 40 millimeters to accept the 40 millimeter shaft. Repeating the process with the thicker flanges that will be inside the axle. Now I'm preparing the shaft to weld on the flanges. Since the flanges are still oversized, I put the axle in the lathe and threw both flanges up to make sure they're nice and concentric to the axle. Here I'm prepping the tube to be able to weld the shafts in. I'll be using some plug welds to weld the shaft to the pipe. After I finish welded the tube, I'm installing some rivet nuts to secure the pull deck to the shaft. Now the tube is done, I'm gonna start on the framework. The frame will consist out of 50mm tubing with a wall thickness of 2mm. I will cut the tube with a bandsaw. Deburring all the parts will make welding a lot easier. First I weld up the C-sections and the square end caps for the frame. After that I will make 3 sections from the frame and these ones will be welded together. To make construction of the frame a lot easier, I will be making it out of 3 sections, 2 outer parts and 1 inner part. Here I'm putting the 3 sections I just made on a flat floor. After that I'll be checking it for squareness. Now I start welding up the frame. I will try to prevent warping by welding short beads at a time. Here I'm making the mounting plates for the bearing blocks. These plates will be welded to the frame. Here you can see me welding the mounting plates for the bearing block on the frame. Now I'm welding in all the support for the decking. I made a small jig to make this easier. Now I'm drilling and tapping all the holes for the M4 thread. I broke a lot of drill bits and taps by doing this. Here I'm using some Scotch-Brite and some aluminum tape to blend in the weld beads. After cutting all the composite boards to the correct size, I'm installing the stainless steel clips to mount the board. Now I can install the composite decking. Using all stainless steel hardware to prevent rusting. Now I'm punching some holes in these straps to be able to mount the pool deck to the tube. Final step in the process is mounting the deck to the tube.